All right, hello everyone. Thank you for coming to this talk about perceived performance. Thanks to the organization for giving me a chance to speak here. I very much appreciate it. So, first of all, I'm Wilson. I work as a UI developer at farfetch.com. You can follow those links if you want to know a little bit more about me. I apologize for my personal website. It's completely empty. I just run a quick node app with a basic HTML just to point to the GitHub account. Either way, I'll manage to get to that eventually. So, I wanted to explain things first with a small example. Now, this was a use case that we worked on last year. And this was how our product detail page looked like before we did some stuff on that. As you can see, there are a lot of different issues with this. Anyone wants to point out a couple of them? What might be a major issue here? No one? Okay. Sorry? The loading time. Well, yeah, of course, the first pointer. But why do you perceive the loading time to actually be? Okay, cool, thanks. It's building up to actually build the structure when it will end up with. So the major issue here for me is we can't add to bag. We need to sell and we can't see the add to bag button from the get-go. Major down point. Other than that, the page keeps jumping around. Things are just popping up, loading, and things are just moving around too much. You don't have a good experience. You feel the page is taking too long to load because you're seeing all this movement. Now, this is what it looked like before. And this is how it looks after. This is the exact same video, the exact same length, except you get an immediate satisfaction from the first load. What happened here was, if you see those little images down there, those are very small thumbnails, very small, low-resolution thumbnails that were already loading in the previous example. What we did was we took this little image, we amped it up, and replaced it where the bigger images, the high-end images, are going to be placed afterwards. So we load up the faster image first. We blur it a bit so it doesn't seem well pixelated. And then we take the blur out with an animation so it feels like it's just progressively loading. It feels much nicer. It gives the user much more satisfactory experience. So, sorry about that. So, perceived performance, what is it really about? It isn't about actual performance. You can do all sorts of things on your server, on your assets. You can do magic to make it be faster, to make everything look faster. But perceived performance is actually how you measure the satisfaction of a user experience, how fast it feels to the user. You can't measure that with analytics or anything else. Of course, you can measure a bit with looking on the bounce rates of different pages, but most of all, it will measure the satisfaction of your user. Now, when does an application feel slow? When the page load takes too long. You're just staring at a screen, like in the first example, and nothing's really happening. So basically, your assets are too big, your server is crappy, your connection is crappy. Maybe you have a very low-end phone, and you're just not having a good experience because it's taking too long. The competition is faster. Well, this relates to the memory of the user, how a user perceives your application when he compares it to other applications. When you have a certain function on your website that exists in a different website, and you relate to it, and you realize that the competition is much faster, and the user memorizes that, and he brings that over to your application. When the page moves around too much, again, first example is the major selling point of this. You're on a phone, you're reading an article, and things just start jumping up and down. You're scrolling, you're just trying to read that one paragraph, but it just keeps jumping up and down. Advertisements are loading, images are loading, all sorts of things are happening, and you just can't read that one paragraph that was so important to you, the whole reason why you were there in the first place, and you have a bad experience. A lack of feedback. Basically, when you click on a button, nothing happens, but then after, 500 milliseconds or so, something actually happens. That delay is a major down point. It makes your application feel like it's dragging. Now, psychologically, how is it really affected? When you give the user high expectations, but the reward is minimal. When you offer them the new best thing about a service, and in fact, he doesn't quite get what he was expecting. When the user is passively waiting, when you are waiting for something to happen, and you're just staring at a blank screen, you have no information to process, it will feel longer. The same thing happens when, you fall asleep for 5 minutes in class, and 5 minutes have passed. But if you are playing a game on your phone for 5 minutes, you end up looking at an hour of wasted time. The problem with technology nowadays is that it has a very short attention span to it. We are reprogramming ourselves into thinking that we don't need to pay attention to things because we want things faster and faster and faster. We want the new iPhone, we want the new Pixel phone, we want the latest attraction, the latest technology, the fastest thing there is. So we have this very short attention span, which is in fact very similar to that of a goldfish. That's a fact, which is a little under 10 seconds. As a cautionary tale, anything that lasts longer than 10 seconds will probably make your user leave the page right then and there. Now, the other thing also applies. If it's too fast, it must be broken. When you have an experience that's just so well catered to you, and you have this really simple registration process or use of a service, it just feels so fast that it can't be true. Now, this is a very specific example from when Google bought the Blogger platform. When that happened, the major point they wanted to focus on was, okay, we'll need to ease the registration process, make it really easy, really fast. Anyone should be able to, with as little information as possible, create a new blog. So they did that. And with just a few clicks, you had a blog, full blog, just ready for action. Now what happened was they started getting complaints of users that were registering the same blog over and over again because they weren't realizing that the process was already done. The success page wasn't enough. They thought, yeah, this was too fast, this failed. I'm going to try again. So what they ended up doing was, after submitting the form, they added a loader that stayed there for a couple of seconds. Now, by doing that, the user thought, okay, something is processing. And then they get the satisfaction of seeing that, okay, your registration is complete, and they moved on. The effect of it was just to give the user a relationship between that experience and his memory. So what can actually be done about it? On the tech side, we have a lot of different things right now. Most of them you will probably hear throughout this conference. One big selling point right now, progressive web apps. Now, they allow you to have offline first, which is a new paradigm, very exciting, which allows you to do many, many different things. Imagine that you are using Amazon as a progressive web app, and you, for some reason, get your internet cut off. Now you're just trying to use the application, but you're offline and you can't. In a progressive web app, you'll do everything. You'll do the purchase, you'll do everything. As soon as you get an internet connection, your service workers will work everything out for you. get new information if they need to, send out the new information that you just input it into your application, and you get the purchase. You don't need to do anything else. And you were offline while doing this. So this is why progressive web apps are the next big thing, I think. You can do a pre-connect, preload, prefetch, and pre-render. Now, these are all APIs that were, until very recently, not supported by Safari. So note that they are, yay. So you can pre-connect to your server, do that little handshake, the first, the first connection. You can preload or prefetch assets in advance. So you're in a product detail page or in a listing page, and you already know where the user is going to go. You prefetch everything from there, and then when you render the page, it seems almost instant. You can also pre-render the whole page in advance. You have to be really confident about it. The critical path. This is basically where when you define the assets and the path that the user will take to get to his goal. You can define, we can explain this a little bit better with critical CSS. When you render a page, the first render of it all should be the fastest. You should get an instant result or an almost instant result. To do that, you can run a gulp task or a grunt task or Webpack task, whatever you feel like it, to figure out which is the essential CSS in that page. It strips out the CSS, sticks it in line in your head, and you have one less request to the server and a almost immediate or very fast rendering time. You can also do code splitting. This is very common in Webpack users. You can gather your assets, your resources, your scripts only when you need them. You can use them only when required. You can go as far as splitting the above the fold content from the below the fold content, so only when you scroll, you get that experience. So let's talk a bit about the tricks. You can make an app shell. Now this concept was mainly introduced in progressive web apps, but it's been around for quite some time now. Then maybe we should already be doing this for years now. It's basically setting up a shell of your application with placeholder content. It means nothing, but it gives the user an immediate perception of what the page is going to get. Now, as you can see there, this is the LinkedIn page, app, and this is the suggesting new connection. So you will get a list with an image and some text. That's the immediate perception you get from this. What this does is gives you something to process while you are waiting. Also, there's that little loading bar on top, which gives the user also a perception of how long he will be waiting, which is also very important. It shortens the passively waiting time. You're now into actively waiting, hence a better satisfactory experience. Now, style the button states. This is very much related to feedback and lack thereof. Now, when you style something, if you are styling a button, it should look like a button. The user should know that he can interact with it. He can do something. He can do stuff there. But usually what we end up doing is we just style the normal state, the hover state, and that's about it. Now what happens most of the time is you end up just scrolling a web page, you try to hit a button, and you're not quite hitting that, you're just scrolling a bit up. So what happens? Nothing, but the hover state is triggered. But nothing has actually happened. That's why the pressed state is very important in this case. It gives the user the perception that something is actually happening. Now, there's another thing about buttons, which is the 300 millisecond delay. Most browsers are eliminating that delay. That happened because the browser was expecting a double tap. So you tap a button, 300 milliseconds later, it checks if another tap has happened, then there's a double tap. If nothing happens, then they trigger the button action. So the body touch action manipulation removes that at all from the page. So you don't have that 300 millisecond delay. But more and more that is happening less and less. Use the right transition. Now, the thing about CSS transitions, sometimes is you can't really point out when is it lagging, when is it your fault, when is it the CPU fault. You have a very interesting concept now on the Google DevTools, in which you can just lag your CPU on purpose to see the effect of a bad animation on a low-end CPU. Now, what we usually do when we transition an element from right to left, let's go with basic stuff, we just, well, most of us, some of us, I don't know, we animate the position. Go from right to left, 300 pixels, something like that. Usually used on menus. And we use the position. Now, we can also use transform translate. We should use transform translate, and this is why. These are 10 elements, 10 different images being animated from left to right, top to bottom, diagonally. One with position left, and the other one with translate X. And as you can see, the performance is much better with translate X. So you don't really have an excuse unless you're supporting IE7 or IE8, and in that case, they don't really want animations, they just want the website. So use transform, you'll be all right. For heavier animations, you can't go wrong with it. It has much less repaint calculations, so it's very low on the CPU. Talking about animations, we should get our timings right. We should go with what feels right. We should cater to our animations to make them feel smooth and fast, native-like. We can do that. We have the ability to do this kind of stuff. When you are evolving, or when you are treating your animations, when you're doing new things, imagine if you have an accordion animation on your website, and you want to do things to it, and you want the user to have a better experience. Weber-Fechner's 20% rule means that the just noticeable difference between the previous animation and the new catered animation should always be 20%. Meaning, if you're going to change your animation values, it should be either 20% more than it was or 20% less than it was. The user won't feel a difference if it's any number in between. 10% won't cut it. The user will just feel like the experience is the exact same. It won't feel like nothing changed. Also, use animation principles. This is a very not so looked at area. You should always take care of your animations with easing, making them feel organic, making them feel like it's something that you can relate to. Have that experience in mind when you know that if you're going to open a menu, the user knows how a menu is going to work. So just make it pop a bit, make it ease in, ease out a bit. Animation principles will always help you give out an idea of something that went right or went wrong. If something went wrong, you can shake things up a bit. You've seen that. It's a very common thing. Do that. Don't think that the user will get that. Use animation to show what actually is happening. You should use the right loader. Now, for anything in below 300 milliseconds, you can use the spinner, the quiet spinner, crowd pleaser. For anything other than that, if the user is going to wait from 300 milliseconds up, 1 second up, you should give the user the perception how much time will pass. You can see that a lot in gaming now. In the early days, you just sat there and waited for your game to load with a spinner. We're all tired of spinners. Do something more. And they did. They give you instructions on how to play the game while you are waiting. So there's less need for tutorials and stuff. The information is right there. While you are waiting, you are educating yourself. The most basic of things is use progressive images. There's no reason whatsoever for you not to be using progressive images. Maybe 10 years back, a study was done by a couple of guys that concluded interlaced images are much faster, they are smaller, they are better. But in reality, they are not. Nowadays, if you do the exact same tests extensively, you will get that the interlaced image isn't better than progressive image. And what you get from the get-go is perception of an image while it is loading. You have something to process. Now, as some closing points, you should always keep the user engaged. That's what the experience is about. You aren't designing a way for me to get some pair of shoes or me to get some really nice sweaters. You are designing an experience from the back end to the front end. Predict decisions is one way you can do that. If you know where the user is going to go and you preload all the content in beforehand, the user will have a better experience because it will seem seamless. You can help with data entry. Anything that can be predicted, like an address, for instance, you can ask for country, postal code. Immediately, you have narrowed down the amount of addresses that there are available. You can now, when the user starts typing his address, predict what the address is going to be and avoid him having to type Avenida Magalhães Fonseca. Give proper feedback. The user must know at any point what is happening. Acknowledge when things go wrong. Forget your pride. Always show that something went wrong. The user will be appreciative of that way that you are trying to engage with them. And now, as developers, we have this big responsibility. We can create something from nothing. We can pick up something that's just a very basic concept and make it something very much larger than it was before. You can create amazing experiences just by looking at the subtle details and by looking at how your user is actually using your application. Having that in mind will also be making the web a great place. So thank you. All the resources are there. The presentation and all of the links that I used for this research. So thank you all for coming and listening to my talk. All right, we have some time for Q&A, if anyone has any questions. Yeah.
Hi. Hi. Hello. Okay. Hi. Thank you for your talk. It's always a nice subject to consider. What I would like to ask you is about the impact of browsers in that perceived speed and how we can control it. Because I remember an old experience that was done between Firefox and Chrome a few years back when they had the same loading time for the pages, but Chrome looked much more, much quicker to load because of the UI animation. The Chrome looked finished. The spinner, the load bar seems already done in Chrome, despite the page was still loading. They did some tricks about that. Yeah. And sometimes when we are loading the pages, we have still content loading, and our page is mainly loaded. Critical CSS minimize it. Ajax lazy loading of images helps it, but we are also dependent on how the browser will load and give feedback about the completion time of the loading. So do you have any tricks to have this consistency in the loading in the browser UI?
When it comes to cross-browsing, I don't think it's really necessary to have consistency cross-browsing because, well, if you're switching from a desktop experience to a mobile experience, the experience is completely different right then and there. So you'll probably be using only an Android phone or an iPhone. You probably won't be using both and you won't be comparing stuff. You could do other kinds of things when you know that a browser is going to be slow, like IE8 for instance, and you need to get some more info out of that. You can detect the browser and of course you can just make it up with fillers. Just filler content, filler things. Just any kind of information that is useful to the user, put it on there, on the loading times. Text to text, it will be there. The loaders will be there. So, yeah, I think that would be it. I can't think of any specific tricks I've used for older browsers, other than just polyfilling stuff and changing animations or removing animations. because sometimes if you have a sluggish animation, you can't really do anything about it. Remove it at all and just make it static. It will feel better than having it dragging out. So yeah, I would probably go with that. Thanks. Yeah, sure, I think. Yeah.
The other question was about font loading, because now it's starting to get consistent. We have an API for that part, but for all those browsers, because of the unstyled flash of text, the
flash of unstyled content, flash of unstyled text, yeah.
Do you have any tools that you usually use for handling that consistency on older browsers?
Usually what we do is we just get the string out of the file and we put it in local storage. We get that out of the way, so caching later on, much faster. You have to do a bit of work on your text, on your font, to make it look like it's the end font. So you can use a system font, all is good, the closest thing you can get. In the background, you load everything up. You save your text on the local storage. You can have, if you do it right, you can have some backups to go to other kinds of stuff, other kinds of storage. You have app storage, app cache, have all those kinds of stuff. And yeah, so basically, system font, do everything, all the work in the background, save as much as you can to be cached in later, load it up when you can. You won't be stopping the rendering, because everything's just working on the background. The only thing you're doing is actually rendering a new style into it, so it should be okay. Cool. Thanks. Anyone else? Fellow in the back.
My question is a little simpler, I think. The real problem sometimes I get is to either make a big file containing every line of code or CSS or JavaScript, or to make smaller files that are only loaded into 1 or 2 pages, and one bigger one that cross the whole site. Should I just make one big with all that jammed in?
No.
No? Okay,
No.
Separate always.
Yeah. You should, well, what you can do is you can have a base file that has most of the essential styles that you're going to get, maybe for, I don't know, Bootstrap, for instance. When you load Bootstrap into something, you will want that, the grid at least, to be across all of the pages. So you know that some of your CSS is going to be across every page. Some basic rules. You have that in every page, like a main CSS file. But then you cater the experience in each page, so you split out everything that's just dependent on that page. You can go even further. You can go into the new React paradigm, and you can have a component that loads its styles only when it needs its styles. You can have a lot of different approaches. I would never go with one whole single file. It hurts your loading time, your immediate loading time, too much. If a user, well, this is more of another Google teaching thing. If the user stays too long without a response on your website, basically if it stays longer than 3 seconds, he will leave. So 3 seconds on a 3G connection to load 5 megabytes won't work. So I would split it up.
Can I ask one more?
Yeah, sure.
So I was thinking about loading screens of the page. So you enter a page, you see nothing, or you see an image, and when the page is loaded, completely loaded, that image or that animation flows out and lets you see the page. What is the best approach to doing one of those things? Like jQuery with window load or something like that, where when that function is called, you just make the foreground
if you really
disappear.
have to do that works more or less like a splash page that you see on a native application. But the splash page is just a splash page. It's just getting in the way. What it's actually doing is it's disguising that you need to do work to render your page. So the app shell thing would probably be a better bet to do that kind of thing, because you can show the user something and not show him a blank screen or a small spinner. But yeah, you can do that. You can overflow the whole screen with a blank screen with a loader on top. I really wouldn't, but you can do that. And you can just use DOM content load and remove it afterwards when everything's ready. Cool. Thank you. Anyone else?
Hi. One way to improve performance is using cache. What's your experience and what is your opinion on managing cache in order to improve performance?
We've been using a lot of local storage stuff. We've been using saving as much data as possible with it. You can use service workers now. The new best thing, basically. They will just give your application a cached state. So it saves in everything that you've done or everything that you need. It's not actually automatic. You need to program a bit there. But it will get your rendering times much faster because everything is cached in the service worker. Let him do the work. Pass it all through there. You should be fine. If you're going to use local storage, you can do the same thing by yourself, but you would always need a system to do that. Don't just, okay, I'll just save it in cookies, I'll just save it in local storage, I'll just save it in app cache, I'll just do whatever I want. Don't do that. Centralize everything, pass everything through the same system, let the system work itself out. Save it where it needs, save it where there's space, eliminate data if there is a need to eliminate data. If you're going to do that by yourself, you should always centralize things. I would go with that. Did I answer your question?
Kind of, that balance between, going to the source of truth versus having something that may not be that fresh, and it's one of the biggest challenges.
Okay.
So what I wanted for you to bring out to us is what kind of good ways to handle this, and because it's a really tough topic in any kind of system.
It's complicated, but we're getting there. You have something very interesting going on with Webpack that basically it defines that if the smallest chunk of code has changed, he just checks if it was just a line change. So that whole file doesn't need to be changed. So he realizes that the base code is the same. The order is just a bit different. So it doesn't do actually anything. It just respects that nothing has changed. It goes to the cached versions. You can also have the small hash thing in front of your CSS. And if you have your code split enough, if it is split enough into very many different pages, you will get that. It probably won't solve the problem that you're trying to solve, but it will help. It's the best thing I can do for you right now. Use a CDN, all the kinds of stuff. You can save new files and new versions. The new package version should get an old CSS, but also the newest one. Mesh things up. Webpack can do a lot of things like that. I'm really fond of Webpack. So yeah. Okay, thanks.
Hey, you mentioned the critical path, and namely the above the fold critical CSS. Do you generate this automatically, or do you do this manually?
The little chunks of code that are changed?
No, the above the fold CSS, the CSS that has to be loaded right from the start.
Okay. So if you split things up into modules, you know what is in the viewport, and you could just use the viewport to recognize which are the things that are going to be loaded. Now, this is doing in runtime. You can predict anything before because you don't know the kind of screen that you're going to get. You don't know where below the content, where above the fold ends. So it needs to be doing all those calculations at runtime and requiring things only as they come up on screen.
Or gulp script, and I got the impression that you could extract this automatically somehow.
Yeah, you can do that for the CSS, mainly for the CSS. You can extract everything else. This is just to improve the rendering time, the initial rendering time. And you're just extracting the essential part of the CSS. It can be the above the fold content. It can be. But it won't always necessarily be the case. You can always be drawing things out in excess. It won't be an exact science. It will help.
Okay. Thank you.
Okay. Okay. Anyone else? We're good? Yeah, okay. Thank you, everyone. Have a great Fix the Scan.